Hi, and welcome to our first lesson in AP Statistics. The first couple of days we're going to be doing a broad overview of the field of statistics. Today we're going to be talking about data exploration, another thing, you could call it data analysis, looking at information, trying to make sense of it. Tomorrow's focus will be trying to make judgments based on data, and that's called inference, but for today we're going to look at analyzing, displaying, drawing conclusions from data. And before we begin, I need to tell you a little story. You're looking at a list here of 14 employees of the Westvaco company, and this is a true story, folks. These people are all hourly employees in this particular department, and Westvaco had economic troubles like many companies across the United States the last few years, and they were told from the top that they needed, from the top management, that they needed to make some cuts. So the person in this department who was responsible for these hourly employees decided to lay off 4 people. You'll notice that there's a 1 here, and it says that that's the round of layoffs that they were let go in. I'll tell you what, this is a sad story, because after the first round of layoffs, management came back and said that's not enough, we need more, and long story short, they did 5 rounds of layoffs at this company, 5 different times laid off employees, and this column in the table represents the round of layoffs in which they were let go. You can see that by the end of these 5 rounds, nobody was laid off in the 5th round in this department. But by the end of 5 rounds, only 4 people left. Folks, this is real stuff happening to real people. And statistics is really about real stuff that happens to real people. So what we want to do is use the Westvaco story to help us define some terms in general and make some analysis of the data that we see. To begin with, the cases in statistics are the individual objects that you're studying. My definition here says the subjects, that's people or objects on which you're making measurements or making judgments. A variable, so a case in this particular story is a line, that's one person. Variables are information about the cases, so characteristics. Each column is a characteristic. So the variables in this case are the columns, like their job title or the month that they were born. Variability in a data set are the differences that the variable can take on. And you might consider this, that variable job title, there are several titles in here. A distribution, folks, we use that term a lot. A good definition of a distribution is the pattern of variability, what those values are and how often they occur. A dot plot is a clever tool for showing variability along a number line. Now we're going to take a look at a dot plot here in just a moment. We are going to construct a dot plot right now that compares the ages of the hourly workers who lost their jobs during rounds 1 through 3 to the ages of the workers who still had their jobs after rounds 1 through 3. And you see I've set up a framework for that. Let's get the data in here again. As you can see, the ages of those employees laid off in rounds 1 through 3 are here. However, we're doing a comparison graph, so we want to make the scale on both of these dot plots, whether they were laid off or retained, we want the scale to be the same. So the lowest age is 22, the highest age I believe is that 64. It looks like if we start numbering at 20 and go by 5s along our number line, we'll be good. So will you pause the video and do that? Let's make the plot, and again on the top graph we're showing those laid off in rounds 1 through 3. So the first worker there in round 1 was 53 years old. This is a dot plot, uses a dot for each case, so there's a dot that represents that 53-year-old. I'm going to continue with the employees who were laid off in rounds 1 through 3. So again, I'm going to ask you to stop your video and let's graph those few people. I think there are 7 of them, maybe 8 of them. All right, here's my plot of those 8 folks. Now we want to look at those who were retained. So that means that we're graphing the rest of the employees, the 0s who never got laid off, and the 2 4s that had an extra round to go. So pause your video and let's graph the retained employees. All right, here's my set of dot plots. And of course, the idea with the dot plot is that you are able to compare. You can look at the data. This is the distribution in visual. So as you look at this, the question here is, how do these ages differ? Now, we may answer differently to that, but it looks to me like more older people seem to be laid off. And that's going to be my observation. More older people seem to get laid off. Of course, that's why we're looking at this story, because an employee at Westvaco sued the company for age discrimination. So as we go through this today and tomorrow, we're going to be looking to see if we can find evidence to back up that lawsuit. And if you looked at these three rounds of layoffs, you might agree. Another way to display data is to show it in table form. And so this summary table, a two-way table it can be also called, shows the ages of people and whether they were laid off or retained. So ages were grouped by under 50. There were 6 employees under 50. There were 8 employees over 50. That's a total of 14 in this department. And of those that were over 50 or older, only 1 was retained. Boy, you might not have picked that up from the dot plots on the previous page or from the table of information, the original table, but it shows up clearly in this two-way table. Let's see if we can answer some mathy questions about this. What proportion of hourly workers under age 50 were laid off? All right, I'd like to draw your attention to this, that phrase of hourly workers under age 50. That's the denominator in our proportion or fraction, if you will. So the proportion of hourly workers under age 50 who were laid off, we only care about the under age 50, and the proportion that was laid off is 3 of 6. Only considering that, or of course 1/2 or 0.5 if you desire. Now I would like you to pause the video and I want you to answer those 3 questions. All right, here's my thinking. Again, the second question asks us about the proportion of workers under age 50, so we were looking still in this row, and it's the rest of them. What proportion of laid off workers? Now we're looking in this column. Of those 10 that were laid off, the number that were under age 50 is 3, so 3/10, and then 7/10 of laid off hourly workers were 50 or older. Now this last question, what 2 proportions should you compute and compare in order to decide whether older hourly workers were disproportionately laid off? To me, the clue to this is here. We're only looking at laid off workers and we want to know about whether older workers got laid off more often. It should be these 2. So if we labeled those proportions 1, 2, 3, and 4, it's the third and fourth there. That's the 3/10 versus 7/10. My conclusion, and yours may be different, but I would say that that's some pretty good evidence that they were, yes, they were disproportionately laid off. Yes. So I'm going to say yes, there was, well, I'm going to say discrimination, okay? Because that's what this case was about. Discrimination. Good. All right, let's go on. This is our last activity of the day, and these 2 sets of dot plots were shown in your textbook, so I clipped these out of your textbook. This display shows the hourly workers. Those are the 14 that we've been discussing. The ages of those laid off are in open circles, and those retained are in solid in each round. So as you look at it, here's round 1. Anybody with an open circle was laid off. So this one was laid off, that one was laid off, etc. By the time we get to the end, we had 1, 2, 3, 4 of the hourly workers left with age ranges really across the board. Okay? As you look at this graph, this is the same comparison only with the salaried workers in this company. Open dots say we were laid off, closed dots say we were retained. And you can see, obviously, there were many more hourly employees. Taking a look, though, at which ones are open circled and which ones are dotted, it's hard to see on this video. You might see it better in your textbook. This is page 7, it says. This display on page 7, this one on page 5, I believe. But what we are to do here is compare the pattern for hourly workers with the pattern for salaried. For which group does the evidence more strongly favor the age discrimination case? Now, you and I may have different answers for that, and it's okay. We're looking at the same data, but it's all right to have different opinions about the data. They're asking us to make a subjective opinion here. And I'm looking at the number of older people at the start of each of these things. And to my eyes, I would say that the hourly workers, I'm looking really around age 50 and above, the hourly workers seem to have taken a bigger hit to me. That is my opinion. So I think the hourly employees or the hourly data shows stronger evidence. My opinion. Now, could you back up that opinion, Mrs. Brownfield? Well, yeah. So I did the counting. Now I want to do the analysis. Over 50 employees for hourly, there was 1 in 8 left, and that is decimal value of 0.125. In the salaried workers here, there were 8 of 20 that were left, and that proportion, well, that's 2/5, so that's 0.4. So I was right? And I can back it up mathematically. Stronger evidence of discrimination against older employees in the hourly workers. Okay. All right, that's it for today. We're going to ask you to get out there and look at the U-Try for this lesson as quickly as you can. See you in school.